Hi dear students, once again welcome back to our channel. We are continuing exercise 9.1, question number 13. As observed from the top of a 75-meter high lighthouse from the sea level, the angles of depression of two ships are 30 degree and 45 degree. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. Okay, see here we have two ships, okay, and we can draw the lighthouse, okay, with respect to the sea level. Okay, this is the lighthouse and whose height is given as 75-meter high lighthouse. Okay, and the same side of the lighthouse, two ships are approaching to the lighthouse. And observer is viewing that ships at an angle of depression 30 degree and 45 degree. The ship which is close to the lighthouse, okay, having this angle of depression is greater than the ship which is come behind the the first one. Okay, that is the meaning. And see, if that observer is at the top of the lighthouse, okay, and this is the line horizontal level, okay, that is first sight. And in order to view this ship which is in the sea, that observer need to lower his head. Okay, so that means from this angle little bit that head should be lowered in order to see that ship. Okay, and at an angle, that is this angle of depression is given as, see, this is the first ship. Okay, and this angle of depression is given as 30 degree. And here this lighthouse, and this is the sea level, children, sea level, and this is the lighthouse. Lighthouse makes 90 degree. So this is a right triangle. So we have to convert this angle with respect to this right triangle. Okay, so this angle, because of alternate interior angles are equal, these two lines are parallel. Okay, so this angle will be 30 degree. So that you can consider this right triangle in order to get the required answer. And for the two ships are there. Okay, for viewing the second ship, that angle of depression is given as 45 degree. Okay, as we move towards this lighthouse, that angles get increased. Okay, whether it is depression or the angle of elevation. Okay, so for viewing the second ship, okay, so this is a second ship and its angle of elevation. So from this horizontal to this line of sight, that is given as 45 degree. So this angle also 45 degree. So this angle is greater than this one, since this is more close to the lighthouse. So everything is okay. See, and what is asked finally? We have to find out that distance between the two ships. That means this is the distance between two ships, and we can mark that points A, B, C and D. That means DC is the distance between the ships. Okay, and for that, children, as I told, we can consider two right triangles, and one is triangle ABC and another one is the big right triangle, that is ABD, this one. And for these two right triangles, this side AB is common. That means we can form two equations with respect to this common side AB. That is the procedure. Okay, and here these angles are given and the height also given, so that you can easily solve this problem. Okay, let us start. So children, we can consider first right triangle, that is triangle ABC. Okay, consider, see, if since here this angle of depression 45, this also 45, so this will be an isosceles right triangle, which means this angle also 45 degree. 45 degrees. So if this is 75, that sides opposite to equal, angles are equal, that means BC equal to 75 degree, 75 meter. Okay, so we can mention that one. Okay, so consider right triangle ABC. Okay, that is right triangle, isosceles right triangle. Consider isosceles right triangle ABC. That means AB equal to BC equal to 75 meter. Okay, so we can write here BC equal to 75 meter because this ABC is an isosceles right triangle. Okay, or you by taking tan 45 also because one, so AB by BC, that case also you can easily get AB equal to BC, that doesn't matter. And in order to get the second one, that means triangle, now consider triangle ABD, big right triangle. Okay, here the angle is 30 degree, so tan of 30 degree equal to AB divided by BD. And what is the value of tan 30? That is 1 by root 3 equal to AB is 75 divided by BD. Okay, BD equal to DC plus BC. BC what we have seen? BC is also 75. Okay, so we can substitute that value, that is 1 by root 3 equal to 75 divided by DC's required distance between two ships, and BC we have seen that is also 75. See, the only variable is DC. That is the distance between the ships. Okay, and you can cross multiply this one. Okay, that means DC plus 75. DC plus 75 equal to root 3 will come to this side, that is RHS, because of cross multiplication, that is 75 root 3. I am keeping this DC alone here, that means 75 root 3 minus 75. This plus 75 become minus 75, and from these two terms we can take 75 common, and root 3, 75 means 75 into 1. So we already have taken 75, there is 1 remaining in the second term, so root 3 minus 1, that is 75 into root 3 minus 1 meter. This is the distance between two ships. 12th question. From the top of a 7 meter high building, the angle of elevation of the top of a cable tower is 60 degree. And the angle of depression of its foot is 45 degree. Determine the height of the tower. It's very important question. Okay, so here we have a building, okay, on the ground. So we can draw the figure. So this represents a ground, and we have a building, and whose height is given as 7 meter. And the angle of elevation of the top of the cable tower is, from the top of the building, the angle of elevation of the top of the tower. So that viewing is taking place from the top of the building. This is the building. Okay, from this building, the topmost position, the angle of elevation, that means we have to raise our head in order to look into the top portion of the tower. That means the tower is higher than that, the taller than this building. Okay, so that means this cable tower, and from this point the angle of elevation. So here the horizontal is parallel to the ground. Okay, that is first side is parallel to the ground. So and that angle of elevation from this point to the top of the tower, this is the cable tower, and that is given as 60 degree. Okay, and the angle of depression of its foot. Its foot means the tower, the foot of the tower, and that angle of depression from this point, that is the top of the building, from this point to the bottom or the foot of the tower, that angle of depression, angle between this horizontal level and the line of sight, and its angle of depression is given as 45 degree. Okay, determine the height of the tower. That means this is the tower, this height we have to find out. That figure is clear, children. So read the question and draw the figure, and we can name these points A, B, C, D and E. Okay, so since this building and this ground make 90 degree here, here also tower and the ground make 90 degree here. So perpendicular. So in order to get the height of the tower from the figure, that is AC. Okay, so from the figure, height of the tower of the tower equal to AC. This whole length from the ground, AC, and AC equal to AB plus BC. Okay, and here AB, this portion is a side of this right triangle. Here it is 90 degree and this line is parallel, and that means this is also 90 degree. Okay, and you can consider right triangle AB. Okay, and its angle of elevation, acute angle, that is 60 degrees given. So you have to consider that triangle in order to get AB. Okay, and also BC, because this AC is a sum of AB plus BC. So that BC is again, here we have the angle of depression is given, angle of depression. And since this line is parallel, okay, and this angle is also 45 degree, because alternate angles are equal. And you can consider now this right triangle. Okay, and these two, building and the tower, are parallel. So this height, that is ED, the height of the building is equal to the height of this portion, that is this portion of the tower, and that is 7 meter. Because this ED and BC are parallel, this also parallel. Okay, so this piece, that is BC, equal to 7 meter, because the height, that is equal to the height of the building. So actually we have to find out the height of this portion, that is AB, in order to get the height of the tower, because BC is also equal to height of the building. Okay, so we need only AB in order to get the height of the tower. Okay, and for that, children, see, since here this angle of depression is given, and since this BE is parallel to the ground, okay, and if you know this distance CD, that will be equal to BE, because they are parallel. BE is parallel to CD. Okay, and this is also equal. Okay, so children, here, since this is 90 degree and this is 45 degree, that means this angle is also 45 degree. That means this is an isosceles right triangle. That means the sides opposite to equal angles are equal. Okay, so that means if this is 7 centimeter, this also 7 centimeter, 7 meter, not centimeter, 7 meter. Which means if CD or DC equal to 7 meter, EB is also 7 meter. The remaining part is very simple. It is clear, children? Since the angle of depression is given as 45 degree, okay, from the top to the foot of the tower is 45 degree, and since these are parallel, so this angle is also 45, because of alternate interior angles are equal. Now you can consider this as an isosceles right triangle, which means this ED equal to CD. If so, since EB equal to CD, because they are parallel, okay, so this side is also 7 centimeter. Now you can simply take the right triangle ABE and you can apply tan of 60 degree. That is, we need AB opposite side by adjacent side. That will be the required height of the tower, and you can substitute over here AC is equal to AB plus BC. That is the content of this question. Understood? We can write all these details and we can find out that answer. Okay. So children, here consider which triangle, children? Here we have isosceles right triangle, isosceles right triangle, isosceles right triangle, which one? EDC, okay, ED equal to DC and equal to 7 meter, because ED is given as 7 meter. Okay, what is the next step? From the figure, BE equal to CD or DC. Okay, so this is equal to 7 meter. That means BE also 7 meter. Understood? Okay. And now we have to consider this right triangle. Right triangle ABE, tan of 60 degree, its acute angle is 60, and that is equal to AB by EB. Or for substituting the value of tan 60 as root 3, AB is the required height and EB you can substitute as 7. So AB equal to 7 root 3. Okay. Since this BC equal to ED, because they are parallel. Okay. So from the figure we can add this also. From the figure BE equal to CD and also ED equal to BC equal to 7 centimeter. Okay. Therefore we need height of the tower, we have taken that as AC equal to AB plus BC, that is equal to AB. We have seen that 7 root 3 plus 7 is BC equal to parallel. Okay. So this is equal to, you can take 7 as common, root 3 plus 1. The 7 is 7 into 1, right? So after taking 7 as common, you will have root 3 plus 1. Okay. And if you know if the value of root 3 is given, okay, you can substitute that as 1.73 plus 1. So 1.73 plus 1 is 2.73. And here is 7 is outside. So 7 into 2.73 meter. So we can multiply 273 into 7, 21, 2 carries, 49, 51, 5 carries, so 19. Okay, 14 plus 5, 19. And how many decimal places? 2. So approximate value of root 3 is a irrational number. Okay, so that means this 1.73 is an approximate value of root 3. So the answer is equal to, that is the height of the tower AC equal to 19.11 approximation. Okay, so this is the height, or this much meter is the height of the tower, that is the TV tower, right? Cable tower. Okay, so very simple calculation, but understand the meaning, this angle of depression and how this 7 comes and out, and finally you can consider this right triangle ABE in order to get the height of the cable tower. So thank you children, thank you for watching and supporting my channel. The remaining problems we will solve in the coming videos. Okay.